All right, so last lesson we did the idea of residual plots. And this is a really good illustration of what the SACE exam questions are like. Number one, you get a set of data. You know that you put that into stat edit, and then you might run a linreg to get the linear relationship of it. All right? And then last lesson I taught you about residual plots. If you draw a residual plot, if the dots are randomly scattered on your residual plot, linear is appropriate. But if there's a shape to it, linear is not appropriate. So the only next step that we do in general maths is once you've tried to fit a straight line to your data and you draw a residual plot, if you come to the conclusion that it's not appropriate to use a linear relationship, we only try one other model. So for example, last lesson we saw that the residual plot of that data formed a really clear shape here, and we said this is not linear. So the only other thing that we do, and this is going to be nice for the methods kids because they know there's a lot of other models that we can try. In general maths, we only try one. We try linear, or if that doesn't work, we try exponential. That's the only models that we try. So let me explain what an exponential regression is. We have just seen that residual plots are used to decide if linear is appropriate for the data set. In our subject, the only other model we try is exponential. So the exponential model we try looks like this. So the notes that I would like you to get are just here. The exponential model we try is in this form. Y is equal to a times b to the power of x. Y is the value of the dependent variable, just like with linear. X is the value of the independent variable. Please notice that x this time is a power in this model. In linear, I'll quickly draw a linear over here. Y is equal to ax plus b. Is x a power in the linear? No, you're just multiplying by it, okay? So slightly different with exponential model. A is the y-intercept in context. It is the starting value of the dependent variable. B is known as the multiplier. It is what y is multiplied by every time x increases by 1. And I'll give you time to get notes down to here, this little star here. B can be used to find the percentage increase or decrease in the dependent variable. If you find B, take 1. Then express it as a percentage. So, I'll give you a few moments to get that down, please. So when you start seeing the past exams, you'll acknowledge exactly what I said here. I asked you to try linear. If you come to the conclusion linear is not appropriate, you try exponential. That's the only other thing we try at general maths level. So no sine, no log, no cosine, no tan, no. Tan's the weird one. The weird one looks like, the tan looks like the, like that or something, doesn't it? Let's not. Shh. I don't want nightmares. A couple more minutes to get the full explanation for what this model represents. It's like the lesson where I said this, y is equal to mx plus c. This is like the lesson telling you m was the slope and c was the y-intercept. This model is slightly different, so I need to explain to you what the bloody letters mean. So this time the a is the y-intercept. A is where it starts. B is how much it's increasing by as a percentage. which I'll show you how to deal with next. Guys, am I going to have a heart attack if I move here? I want to explain how you deal with B. So I just said that B can be used. B can be used to find the percentage increase or decrease in the dependent variable by finding B take 1. So let's do a couple of examples here so you can see how that's interpreted. If my exponential model was this, what do I know about it? Which one of the, what's A in this model?
2.
Which 2? Good. So Y is going to start at 2. So we know already that this exponential model is going to look like, it's going to go through the y-axis there. All right? Now we look at this number, B, 1.23. So I just told you we can find the percentage increase or decrease by finding B take 1. So what is 1.23 take 1? What's left over? If I go 1.23 take 1. 0.23. 0.23. So Y, B starts with, so what is 0.23 as a percentage? Good. So what is that telling you about what Y is doing? It's increasing by 23% every 1x. So how is this graph going to curve? Is it going to curve upwards or is it going to curve downwards? Up, because it's increasing. Okay, so I don't know, I don't have a scale here, but we know because B is greater than 1, it's going to curve upwards. And how fast upwards? It's going up by 23% every time. Now if we look at the second example, what's Y going to start at here? 3. Good. So I know that the graph, I don't know where it's curving right now, but I know it's going to go through 3 there. But what is B this time? Is B greater than 1 or less than 1? Less than 1? So if I go 0.75, take 1, what number am I going to get? Negative 0.25. What is that as percentage? Negative 25%. So what is that saying about Y? Is it increasing by 25% each time or decreasing? Decreasing by 25%. So what is, sorry, oh, I was about to sneeze. What shape is, that's on the YouTube video. What shape is this graph going to be? It's going to go through 3, but what way? Curve up or curve down? Curve downwards. So it's going to curve like this. Okay? So can I give you a couple of moments? Can you get this little explanation for handling B for now? Brody, that video is going off. Yeah, I might have 4,000 views or something. 96 likes or something? Who would have thought that a little Asian man carrying 152 kilos would get so many views? I asked Mia to sub and like. Huh? Yeah, that's a sore point. Let's not talk. That's it. Just like a minute or so to get this little explanation about B. And then I'll show you how you actually do questions involving exponential. A little longer lesson today because it is a double lesson. We're still on track for you to do an in-class practice test week 4, which I will try to mark very fast. It just sucks that your next lesson after the Thursday is the Friday. Okay? But I'll try. Right. So, now you are aware of the form of exponential model that we deal with. You need to be able to generate an exponential model for data using your calculator. How do we achieve that? How did you achieve the linear regression? Lin-Reg. How do we achieve exponential regression? Well, it's going to be called XReg. So what are the steps? These are important for now, but if you're thinking logically, you probably don't need to chuck this in your calculator, right? Because you should have practiced so much that you know, how do I enter my data? Step 1, stat edit. What should I put into list 1? Which of the data should I put into list 1? My X variables or my Y? X, form that habit. My Y variables go into list 2. So I'll demonstrate that. Stat 1, edit. I've got a bunch of data in there. I'm going to clear L3. So I've got a bunch of data in list 1, list 2. You can't see that, sorry. What do I do now? Press stat. Select calc. You can't see it right now. What's the furthest down that I can see? Quart reg. That doesn't help us because we're not methods kids. We're not going to model a quartic. So you scroll down all the way to 0exp reg. What does exp stand for? Not XP, not experience. It stands for exponential regression. So you press enter on that. You scroll down and select calculate. And what have you asked the calculator to do? You've asked the calculator to fit an exponential curved model to your data. Can you see on the screen there that it tells you what A is in the model? The A is telling you what A is in the model. Can you see that it tells you what B is? Can you see that it tells you what R and R squared are? So those still tell you how well the model fits. Okay? So another, let's say, few minutes. If you need these steps, go for your life. I'll give you a pause there. To get those steps down, how to get an exponential regression. You want to try and record your 150 attempt? Start a YouTube channel? Upload it? See if you get some. Try. If you do, I'll be so proud.
I'll do about the dog.
Huh?
I'll do about the dog.
Oh, you're going to flex on me, are you?
Exactly.
Mr. T needs a belt to lift.
I want to try with that, and then I want to try with, as well as these as well. Wrist straps.
Oh, that's too much.
That's too much?
Look at him, he's vinyl. The stuff is vinyl. Gear. No, we were struggling with 107 at the start of the year. Respect the grind. Okay, no heart attacks here. Let us do an example. So I will give you time to get that example down so you can see the whole process. The mass of any bio kids in here? Yep, so this might be an example that you'd encounter in bio. The mass of bacteria in a culture is measured each day for 5 days. This is the data that you're given. So obviously time is the independent variable, and it's going to explain why the amount of bacteria is growing. Because bacteria divide, what is it called? Binary fission. So get that table down and the context of it, please. Draw the scatter plot. I'm not going to demo putting the points on because I shouldn't need to demo putting a scatter plot up now. I pre-did that, so we focus on what's new. So get the data. Get the data, maybe leave space so you've got space to do a scatter plot. What I want to demonstrate is B and C. So a few minutes there. Can someone tell me how I would find the exponential model for this data? What do I need to do first? Is my calculator currently aware of what that data is right now? No? Where do I put data in the calculator? Yep, stat, edit. The very first lesson I showed you stat edit, I told you do not press the delete button. If you press the delete button, it deletes the whole bloody column and you have to reinsert it. So the best way to deal with things is always press clear. So you go to L1, clear. It's asking, what do you want in L1? I want nothing in there. Press enter, okay? I don't want you wasting time clearing every one of those, especially if it asks you to put 12 bloody bits of data in there, okay? So highlight the column, press clear, enter. It's fresh now. So I put my X data in, 1, 2, 3, 4, 5. Y data, 3.6, 5.7, 9.1, 14.6, 23.3. The data is entered. The calculator is aware of it now. How do I get the calculator to try to draw a curved line through that? What's new today? What do I press now to get an exponential model fit to it? Stat? Calc? Yep, so you scroll down, it's off the screen, scroll down to 0x per edge. Because you've formed good habits, like I stated at the start, list 1, list 2 is your x and y. Press enter. So it's saying that's pretty damn good. That's a pretty strong fit. Why? Because r and r squared are like so close to 1. What is that saying about the model? That is telling you that the model, the A is 0, not 0, 2.25 to 2 decimal points. B is 1.596. I'm looking at the 6. What's 6 going to do to the 9? Push it up by 1. So to decimal points is going to 1.60 to 2 decimal points. So what is the exponential model in this form? Well, the mass of bacteria is going to be 2.25 times by 1.60 to the power of, that's the worst T ever drawn, T. That is the exponential model in context of the question, okay? When you do your test, you will notice that it will always ask you, can you draw the exponential model in terms of this m and t? If you leave it as y and x, you will lose a mark because that's not in context of the question. Transform it to this. Can we do some interpretation of the values of A and B in context? So what is the 2.25 telling you about the bacteria? What was A? A was the y-intercept, the starting amount. So what was the starting mass of bacteria according to this model? 2.25. The starting mass was 2.25 grams. Let's interpret B in context. So 1.6, so that was A. B take 1. 1.6 take 1 is going to be 0.6. What is 0.6 as a percentage? Therefore, 60%. So what can we say about the mass of bacteria every day that it's growing? How much is it increasing by? How many percent? 60. That's how you interpret the exponential model. So therefore, the mass is increasing 60% every day. That's an exponential model question. I'll zoom out slightly so you can see the scatter plot. So some time to get this down, please. I know you want me to be done. We're not done yet. Almost done. The only makeup I'll do for it is on Friday. It'll just be a catch-up lesson, okay? I won't teach anything new. But if I break it up, it doesn't flow properly, okay? Question?
When would we need to use this? Like you said, if it's not linear or something like that?
Yes, so the flow of your exam questions in the past has been fit a linear regression to the data. Draw a residual plot. And if the residual plot has a shape to it, your conclusion is linear is not appropriate. So then what do we do? In general maths, we try this. That's the only other thing that we try. If it doesn't fit to linear, we try exponential. If you were doing methods, you'd try log, you'd try sine, you'd try all this other crap. We only need to worry about one thing. Linear is not right, exponential is the next, okay?
Okay. Is that trying to make a line?
Yes, because can you see with this scatter plot here, can you see a strong curve? If we did a residual plot to this, the residual plot would have a real shape to it. So there is no point trying to fit a line to this. We need one other model. The only other model that we try is exponential, okay? All right, moving on. So the last thing that we need to do, it looks really big because we are doing general. This predicting independent x is really bad. So, like the least squares line equation, we can use the exponential model to predict values for x and y. What you want to hope is that it asks you to predict the dependent variable. So, what are you predicting? You're predicting what y is. You're finding that. This is easy as the model is written to find y. So all you need to do is substitute x into this and solve for y. That's easy to do, but if you're predicting the independent variable x, so you're trying to find the power of x, that's harder because in general we do not do hard enough maths to rearrange a power. Methods kids, this would have been natural logs, and you're not going to be marked down if you running out of time and you use natural logs to find this answer, if you can remember it. But because we're general, I have to show you how to do it with a calculator. So can you please, for now, get this, predicting the dependent variable and the instructions for it, substitute x in and solve for y. So, yeah, this one, I'm happy with you if you're a bit butthurt about this one, predicting independent x variable. This is harder because we don't do the algebra or the maths you need to just do it by hand. What we do in general maths is we draw, we use graphing. You open the graphing tool, you press y equals. So this button here, you can see I was just doing one previously. In y1, you enter the left-hand side of your exponential model. In y2, you enter the right-hand side. You press zoom and go zoom standard. And it draws the graph. But you can't see anything there, right? Why? Because this is zoomed 10 by 10. And if I look at my graphs, y1 is at 8,000. So is there any possibility in that zoom standard that I could see a horizontal line at 8,000? No, I'm not going to see that. What is the y-intercept of your y2? It's at 1,000. So it's not zoomed in properly to see that. So what you do next, once you've entered those things, you're asking the calculator to draw a horizontal line here and your curve here in y2. You press zoom and zoom standard, and you won't be able to see anything. And so what you do now, the remaining steps, you zoom out. So zoom out, and you just keep zooming out until you see where they cross over. Can I see where they cross over yet? I can see where it curves, but I don't see the horizontal line. So zoom out again. Can I see the horizontal line yet? I just see the curve. Zoom out again. Still don't see the horizontal line. So I'm getting further and further away. Still don't see it. It's super pixelated. It's like an Xbox 360 here. Can I see the horizontal line now? Is the curve on there? It's just, it was. It's just really hard to see because there's so few pixels on the screen. I'll zoom in again. Can you see a little bit of the curve there? There's like pixels of it. You are zooming out enough that you know for sure, are they crossing somewhere on the screen right now? You've zoomed out so much that they're definitely crossing there. You just can't see it because the pixels are so bad. Okay? The crossover is there. So what do you do now? You press second trace. So can you see above the trace button, can you see how it says calc in blue? Yep. So you go second trace. Which of those ones do you reckon finds the intersection? 5 intersect. And it goes first curve. It's asking you, is that the first thing that you put in? Is that what we put in? 8,000? So you press enter. Is that the second thing that I put in? Enter. It's asking you, would you like to find the intersect? Even though it says guess. I don't want you to guess it, but that's what it asks you. I want you to find the intersection. That's where they intersect. And can you see that it tells you what x is? That's your solution. X, the x value of the intersection is the value you need. All right? So it is annoyingly long that we can't do that using algebra. But the only way you would solve that by hand is with something called natural logs that you would have heard of and you would have heard of as well. We don't do that at general maths. We have to do it with the calculator, and we get the calculator to work out where they cross over. All right? Can you get that down, please? Did you have a question?
Yeah, how do you get the algebra calculator?
Which one? The graphing?
Yeah.
Yep, so y equals, so this little button here is how you draw the lines. So the last thing left in this lesson is for me to demonstrate doing that. So yeah, still a bit longer to get those steps down, please. And then I want to demonstrate it. And then you can stop listening to my annoying voice, all right? After I've recorded, would you like to practice using ln? I want to see if I remember it. From Fleef, yeah. It's not fun. Is anyone going to have a heart attack if I demonstrate this now? Yes? Okay, you will have a... This is the first time for... There's a lot of steps there, I'm sorry. You can chat, don't say anything silly, and name each other, please. You can chat a little bit. Don't talk about driving unsafely. Or questionable content. He's a safe driver, he's got 4-wheel drive.
So you should see how far it gets off times.
I said no. Actually, I said butt hurt before, that's right. No heart attacks anymore? Alright. We are going to continue that previous example with the bacteria. So we established that the model was that. our model was m is equal to 2.25 times by 1.60 to the power of t. So we're going to answer D. Predict the mass of bacteria in the culture after 7 days. This is the easy version. M, when the days is 7, is equal to 2.25 times by 1.60. What am I changing t to?
5.
No, it's asking for 7.
Oh.
We want after 7 days. Right? So to the power of 7. So I go to my normal calculator function. 2.25 times by 1. Is that still showing on the screen? Yeah. 1.6. The power button is, sorry, it's cut off a little bit. The power button is that little hat symbol there. Okay? To the power of, see how it makes it small? 7. So that is telling you m, when it's 7, is equal to 60.40 grams of bacteria after 7 days. Easier process, right? But the problem is, if it's asking this, how long, right? How long will it take? Is it asking for you to find t this time? We don't do hard enough maths to do that by hand. So what we are doing is, how long is it going to take for the bacteria to reach 100 grams? So it's telling you the model is 100 is the mass, equals 2.25 times by 1.60 to the power of, I don't know what t is. So what am I going to graph? In y1, I'm going to graph the left-hand side, 100. In y2, I'm going to graph the right-hand side, 2.25 times by 1.60 to the power of t. So can someone remind me, how do I go to the graphing part of the calculator? What button do I press? Y equals. It's on the left here. Y equals. I'm going to clear this because that's existing data. I'm also going to go to the Zoom standard. So what does the left-hand side of my model look like? 100. What does the right-hand side look like? 2.25 times by 1.6 to the power of... So this is weird. The way that you get x, can you see this button here? It's got an x, t, theta, and n. That's how you get x for this. Can you see how I made a little x? You're not going to do the letter x like the alphabet. You're doing variable x. So you press this button here, x, t, theta, n. So do I have both sides of the model in there? It's going to draw a horizontal line at y is equal to 100. It's going to draw an exponential curve that starts at 2.25 and it goes up by 60% every time. So press zoom, standard. Am I going to be able to see it to start off with? No, because it starts at 100. So I can't see anything except for the curve because that went through 2.25. So what do I do now? Zoom out. Zoom out until I can see the crossover. If you've got the newer calculators, I don't actually think you need to zoom out all the way, but this is just safer. Zoom out. I don't see the horizontal line yet. Zoom out. Is the crossover on the screen at some point? I just can't see it properly because the resolution's crap. So what do I press now to get it to calculate intersection? Second trace to get calc. Find the intersection. Oh, that's not what I wanted to do. Intersect. First curve was 100. Second curve was that. What do you think? Guess? I don't want you to guess. I want you to tell me the answer. That's the intersection there. So for your answers, you would write intersect at 8.07 and 100. So therefore, what is that saying? 100 grams of bacteria at how many days? How many days is that x-intersect telling you? 8.07 days.